Hello, my name is Moritz Gruber and I'm here to present to you our latest research. We may share the number of diaper changes, a privacy and security evaluation of mobile childcare applications. This work was a cooperation of the Institute of Internet Security in Gelsenkirchen, the Aware 7, Secunet and the Max Planck Institute in Bochum. Our research team includes a few young fathers, and therefore calls or WhatsApp messages with information from childcare are our normal everyday life. But besides messages via WhatsApp, there are also apps for communication with childcare. Therefore, we decided to evaluate childcare apps in more detail. First of all, we were surprised by the wide range of functions these apps offer. If you take a closer look at our example screenshots, you get an impression of those. They allow the employees of a daycare center to manage the data of children or to communicate with the parents. Furthermore, many of those apps allow parents to share data about their children or to get in touch with other parents. The functionality of some of those apps is quite familiar to that of a social network like, for example, Facebook. Our goal in this work was to evaluate how the security of our children's data is handled in such apps. We wanted to look at the whole project from a privacy point of view and from a security point of view. In total, we looked at 42 apps for Android. Those apps are identified by searching the Google Play Store for terms like childcare app or preschool management apps, as well as many others. We then manually evaluated all these apps we found according to the following criteria to determine if they fit in our scope. The first criteria was the app is intended for the childcare sector. The second was the app should be used for the communications between parents and childcare workers. And lastly, the app provides a management interface for storing data of children and processing and managing it. In the end, 42 apps remained. These apps together have over 3 million users according to the Google Play Store. The largest market share are held by Blooms and Brightwheel, with over 1 million users each. All these apps process highly sensitive data such as names, addresses, behavior of children, photos, videos, their current location and even health data. All this data is considered to be highly sensitive. To ensure the privacy of minorities, the regulations of GDPR and COPPA-Serve. We use those regulations to evaluate the privacy policies of the 42 apps. Since we wanted to analyze the apps from a security and privacy point of view, this was our analysis pipeline as shown in this image. Each of the examined apps was decompiled and statically analyzed. Afterwards, we performed a dynamic analysis of the apps to capture their behavior and communication live. We finally took a closer look at the privacy policies of each of those apps. In a static analysis, we used a wide variety of tools to identify, for example, misconfigured Firebase database used by those apps. Furthermore, we took a closer look at the permissions set by those apps and evaluated which dangerous permissions are used. We took the definition of dangerous permissions from Google's Android documentation. Lastly, we looked at the libraries which are used by the app and whether they are outdated or are built insecurely. For the dynamic analysis, we examined the apps with an interception proxy in order to be able to read and evaluate the external communication of those apps. So we could evaluate the communication to the backend and how TLS is handled by those apps and backends. Another important point was to evaluate how the data of the app is stored. And therefore, we looked at the data of the apps locally on the Android smartphone. And we also tried to find insecure cloud storages used by those apps externally. Furthermore, we looked at the backends for common vulnerabilities in such apps, such as insecure direct object referencing, short IDOR, or outdated software components or other vulnerabilities. We also looked at the privacy policies of those apps manually, since almost a third were not written in English language. We took the privacy policy from the link in the Google Play Store. Among other things, we evaluated whether the privacy policy mentions the processing of data of minors. It was also interesting to us whether the privacy policy lists which data is stored and which data is processed. We also wanted to evaluate whether it is possible to read out one's own data. 11 of the privacy policies examined did not describe the app in the first place, but the website of the provider or the whole privacy policy of the provider, but they didn't mention the app at all. 1/3 of the apps did not list any data they store or process at all. We found it particularly surprising that only 96% of the privacy policies mention that they process or store data from children at all. But this is their only purpose. These are apps for processing and storing data of children and communication with those parents. In the table shown here, we see a section from a table from our paper. This clearly shows how diversified the results of our privacy analysis were. A good example for a poorly maintained privacy policy would be the app Hokita, which does not mention processing of data from children in its privacy policy. Also, this is obviously its purpose. Furthermore, no information about the trackers used or the data stored or processed is described in this policy. The situation is similar to the app's parent zone or Stramplerbande. On the other side, a positive example is the app Daily Connect or LiveKit, which met all our requirements and lists their privacy policy that they process data from minors. Furthermore, they list which data this is they process and store and which trackers they use. Besides these, there are also many apps like Hi Mama or Kaimbu that only lists part of the required data, which only shows how to devise the results in this sector are. And this only shows how many work there is to do for those companies to fix their privacy policies. The majority of apps examined doesn't support security features such as certificate pinning. This is a feature which would make much more difficult for a man-in-the-middle attacker to read and listen to the communication or to manipulate it. 89% of all apps we examined still support outdated Android versions, like Android 2.1. These are versions that are no longer supported by Google and doesn't get any updates from Google at all. We also found that 30% of the libraries we statically analyzed were either outdated or compiled with the necessary security flags. Functions such as address relocation or stack canary or non-executable stacks were missing on those libraries. We also found that 70% of the dynamically analyzed backends we examined used outdated components with known vulnerabilities. This means that vulnerabilities with CVEs are known for a large part of the backends analyzed. In the dynamic analysis, we also looked whether the backends are susceptible to common vulnerabilities. This was the case for 10% of the backend servers. We found SQL injections, GraphQL injections, and also insecure direct object referencing vulnerabilities and many others. All these apps allow an attacker to access data of other users through such vulnerabilities. We also identified cloud storage in 12% of the apps. This was particularly alarming, as the most sensitive data could be accessed unencrypted and unsecured on the internet. There were Amazon AWS buckets and Firebase databases which contained chat messages, pictures of children, videos, and user data such as email addresses and clear names. Overall, it should be noted that a large proportion of the apps studied use insecure and incomplete privacy policies. This is especially a problem as more and more childcare institutions will rely on digital communication channels and applications and use services like WhatsApp if there are no simple but secure solutions. To improve the situations, guidelines and checks for the evaluation of childcare software and its development should be written in the near future. And these guidelines can then be used by political actors to make manufacturers change their way of building applications. Finally, a dialogue with the manufacturers and developers of such apps should be initiated. This should enable them to understand the responsibility of the data they process and how it can be protected. In our opinion, these are the most important takeaways from our analysis of childcare apps. Thank you very much for your attention, and we look forward to answering your questions.